What if the future of space travel is not speed, but stability? We are so used to thinking of space as this intense sprint for survival. Cramped rockets, constant danger, brief missions with zero margin for error. But in today's Explainer, we're going to explore a totally different possibility. Welcome back. We're going to look at how general emergence mechanics, or GEM, paves the way for calm, long-term orbital living. We're taking the long view.
When you're trying to build a self-sustaining community floating in the void of space, you really have to ask this foundational question: what makes a thing a thing? Why do complex structures, whether that's a massive space station or simply the healthy flow of people living inside it, persist over decades instead of just breaking down into chaos? In deep space, you can't assume your environment will keep you alive. Stability is something you have to actively create.
And that's exactly where the GEM framework comes in. Now, I know you guys already know the basics of GEM from our earlier explainers, so we won't rebuild the whole framework from scratch today. But remember, GEM tells us that stable existence dynamically arises from persistence within a coherence shell. An orbital habitat is, quite literally, a giant engineered coherence shell. It has to actively resist breakdown and recover gracefully from disturbances to keep human life going.
Let's look at the three coupled axes that make this long-term survival possible. First, we have depth. That's the habitat's raw resilience, the ultimate energy barrier against total system failure. Then, stiffness, how well the life support systems resist immediate, sudden shocks, like a solar flare. And finally, viscosity, the recovery speed. If a garden module loses pressure, how quickly does the whole system adapt and bounce back? If any of these drop below a critical threshold, the habitat doesn't just fail, it ceases to be a coherent system altogether.
I always come back to this brilliant quote from the source material. It tells us that persistence isn't just a property of matter, it's the defining boundary of reality. And in the context of long-duration space travel, this is incredibly literal. If we build a spacecraft that lacks the depth or viscosity to handle a 50-year journey, it simply fails to persist. It becomes a ghost ship. To thrive in space, we have to engineer persistence itself.
The sheer beauty of GEM is how universal it is across totally different domains. Whether you're dealing with the physical fatigue of hull materials on a rotating space cylinder or managing the flow of resources and people, like traffic control, through major transport hubs in orbit, the underlying mechanics are exactly the same. You are managing stress and recovery to keep the whole community in a stable, comfortable flow.
And this completely reframes how we should think about spaceflight. Standard control is that rocket mentality, right? Pushing for maximum output, maximum speed, running right on the razor's edge of disaster. But GEM control? That is proactive persistence. It's creating environments that sustain life, health, and meaning over a long period of time. We aren't just trying to shoot people to Mars as fast as humanly possible. We're designing graceful, moving communities that maintain deep stability long before a breakdown even threatens.
This brings us right down to the human scale. Our sources outline a fascinating concept: the biological coherence pod. Think of this as the ultimate blueprint for space habitat life support. It's a body-scale environment actively supporting human biological homeostasis. Imagine your living quarters on a slow-cruising interplanetary ship acting as a dedicated persistence support system, using these very mechanics to accelerate healing, manage the deep fatigue of spaceflight, and keep you completely healthy for decades.
So if we can engineer these coherent shells for our bodies and our spacecraft, what happens when we zoom out? What about the actual ocean we're sailing through? Because to truly understand long-term survival in the cosmos, we need to understand the ultimate persistent structure, the fabric of space-time itself.
The sources dive into modal theory, which shows us this incredible Z3 orbifold geometry. Initially, it creates three perfectly equal vacuum basins. Picture them like three identical valleys. But then, a subtle math quirk known as a loop-suppressed chiral bias slightly tilts this landscape. Because of that tilt, the basin sitting at exactly 255 degrees dynamically emerges as the deepest, most stable global minimum. That 255-degree basin, that is our universe. It is the ultimate self-stable habitat. And that underlying geometry dictates something truly profound. Exactly three. Three distinct universes are predicted by this framework, separated by infinite persistence depth walls. It's like there are three massive, cosmic coherent shells sitting side by side, but the walls between them are infinitely thick.
Contrast this with standard string theory or eternal inflation, which give us these wildly unconstrained landscapes with 10 to the power of 500 random universes. GEM paints a picture of a precise, geometrically constrained reality. Just 3 universes. It's a highly stable, tightly bounded system, which honestly gives me a lot of comfort when we're talking about living long-term out there. We live in an ordered neighborhood.
Because our 255-degree basin is the deepest, it's the one that provides the absolute richest conditions for complex persistence. This is exactly why chemistry works, it's why biology works, it's why we can even build orbital gardens and complex life support systems in the first place. The 60-degree and 180-degree basins are shallower, relic minima with completely different relaxation timescales and physics. But we are lucky enough to live in the deep basin where long-term, beautiful coherence is actually possible.
And here is where it all comes together for the future of space travel. This isn't just abstract, untestable theory. The math predicts a very specific tabletop thrust profile for a local coherence shell, peaking right at that 255-degree global minimum. Think about what that means. We are looking at the potential signature for entirely new graceful propulsion systems. Not violent, explosive rockets, but field-driven coherence drives that could cleanly power those slow, massive, sightseeing journeys through the solar system.
Which leaves us with this incredibly beautiful long view. Now, of course, these are possibilities, not promises. Building closed life support systems is incredibly hard. But maybe the real future of space isn't about learning how to survive for a brief, terrifying moment in the emptiness. Maybe it's about learning how to carry coherence with us wherever we go. From the speed of light to the quiet, rotating gardens of an orbital habitat, it all comes down to the art of persistence. Next time, we'll look at how we might scale these exact principles to weather shaping and planetary stability. But until then, keep wondering what makes a thing a thing.